Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on acid-base concepts. In our last lesson, we discussed the Brønsted-Lowry concept of acids and bases. We learned that according to this concept, an acid is a substance that donates a proton to some other substance. A base is a substance that is capable of accepting protons. We also learned how protons are transferred during acid-base reactions and how to identify acids, bases, conjugate acids, and conjugate bases in given reactions. We learned that the Brønsted-Lowry concept of acids and bases broadened that of Arrhenius by including reactions that are not in aqueous solution. In today's lesson, we will define acids and bases by the Lewis concept, and we will look at some examples of each. We will also learn about electron-pair donation and acceptance. We will discuss how the Lewis concept has broadened previous concepts of acids and bases while remaining inclusive of them. Let us begin. Students, do you remember learning about Gilbert Newton Lewis in previous lessons? In 1923, he produced a definition of acids and bases. His definition furthered the concept of acids and bases even more than Brønsted and Lowry had. According to Lewis's concept, an acid is a substance that can form a coordinate covalent bond by accepting an electron pair from another substance. In other words, acids are electron-pair acceptors. Let us look at an example. This diagram shows a reaction between boron trifluoride, which is the Lewis acid, and ammonia, which is the Lewis base. The boron atom, which is part of boron trifluoride, only has 6 electrons in its valence shell. Thus, it requires 2 more in order to satisfy the octet rule. Consequently, boron trifluoride accepts a pair of electrons from ammonia. Students, are all Brønsted-Lowry acids also considered acids by Lewis's concept? How does the Lewis definition of an acid expand upon the Brønsted-Lowry definition of an acid?
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello, everyone. I wonder how you answered these questions. If you answered that yes, all Brønsted-Lowry acids are also considered acids according to Lewis's definition, then you are correct. The Lewis definition expands upon the Brønsted-Lowry definition by including ions or molecules that are able to accept an electron pair that neither releases a proton in aqueous solution nor donates a proton. I am sure you had no trouble answering those questions, students. It is also important to note that all Arrhenius acids are also considered acids according to Lewis's definition. As the acid releases a hydrogen ion in aqueous solution, the released proton, or hydrogen ion, accepts a pair of electrons from a water molecule to form a hydronium ion. Students, in Lewis acid-base reactions, we should look for two things. First, we should look for a species that has an available empty orbital. This will allow it to accommodate an electron pair, such as the boron atom in boron trifluoride that we looked at earlier. Second, we should look for a species that has a lone pair of electrons, such as ammonia. According to the Lewis concept, a base is a substance that is capable of donating a pair of electrons. In other words, bases are electron-pair donors. Any molecule or negatively charged species that has lone pair of electrons can be considered a Lewis base. Any molecule or positively charged species that is deficient in electrons or that has vacant orbital can be considered a Lewis acid. Students, in a moment, you will see a list of reactions. Please identify the Lewis acids and Lewis bases in each of them. I will see you in a few.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello again, students. Were you able to identify the Lewis acids and Lewis bases in these reactions? Let us identify them together now. For reaction A, silicon tetrachloride is the Lewis acid and chloride ion is the Lewis base. For reaction B, phosphorus pentafluoride is the Lewis acid and fluoride ion is the Lewis base. For reaction C, copper 2+ is the Lewis acid and ammonia is the Lewis base. For reaction D, carbon dioxide is the Lewis acid and water is the Lewis base. For reaction E, nickel is the Lewis acid and carbon monoxide is the Lewis base. Students, I wonder how many of those you answered correctly. If you were able to answer them all correctly, great work. In today's lesson, we discussed the Lewis concept of acids and bases. We learned that Lewis defined acids as substances that can form coordinate covalent bonds by accepting electron pairs from other substances. Bases are substances that are capable of donating pairs of electrons. We also learned that Lewis furthered the Brønsted-Lowry concept by including ions or molecules that are able to accept an electron pair that neither releases a proton in aqueous solution nor donates a proton. This brings us to the end of our lesson for today. Until next time, thank you, teacher. Thank you, students.